Good morning.
Good morning.
Everyone's doing okay. Hope everybody had a great weekend. We'll get started today. So we're going to finish up with our advanced framing. And this is a really good guide here that I'll be referring to. And I'm going to put that up on the Moodle site for you guys to get to. Man, it's awful quiet. Nobody has had their coffee this morning. Let's see. My computer's running a little slow today. Well, where to put it? I'll just need to create a section. Now we'll put it up here at Green Building. Okay, so we have talked about putting our framing at 24 inches on center. And we've talked about using 2 stud corners and ladder tees. And I found a nice picture here of the insulation. So, you know, when we're using corners like this, then it becomes, you know, problematic because we're trying to squeeze more insulation into it. And I just realized how come I couldn't hear nobody. I had my dadgum speaker turned off. Jesus. Yeah, I woke up about 4 o'clock this morning. My computer was dinging and carrying on. I just turned it off. So I apologize. Geez, no wonder. I thought, man, ain't nobody awake this morning. So as you can see, you know, the insulation gets squeezed into places, you know, in the corner where we have a lot of studs. Now, one of the biggest problems that I see in insulation is they will take insulation that is, you know, made for, in this case, 5.5 inches. These are 2x6s, and they squeeze it. I mean, they just compact it down in here. So whenever you're taking, especially fiberglass insulation, and you're squeezing it into a smaller section, you're, in a sense, getting back to a solid piece of glass. So a solid piece of glass is a conductor of heat. And then, so, you know, glass itself is a conductor, but then, you know, when we're using it in a fluff like this, we're causing a lot of air pockets in here. And that is where we get the insulation, is all those air pockets. So when we're squeezing it together, we're making smaller air pockets. And like I say, in a sense, we're getting back to a solid piece of glass. So, you know, corners like this with the clips on there are better to use. Now, if you are doing a 2-stud corner like this, and we've kind of discussed this, then, you know, if we put the side, let me just open this up where I can draw it. So, you know, if we were doing a corner like so. Then right here, we have nothing to, attach our siding to. So instead of doing the, corners and then what we call them a butt corner, then turn my phone off.
So I don't use my glasses.
What's that?
You enlarge that since you're in paint, so I don't use my glasses.
I'm not in paint, but
Oh,
maybe. Yeah, there we go.
yeah, thank you.
Didn't know I could do that.
Yeah, so I don't have to squint.
Okay. So instead of using a butt corner, so what I mean by a butt corner is we put the siding trim on there, and then we butt the siding to it. We use the trim on top of our siding technique. Now, if we were using lap siding, obviously this would be kind of problematic because, we've got to put up with, I can't even draw today. I ain't had enough coffee. Then we have, this is what we got to deal with. So, but if we're using like a board and batten vertical siding or even a panel type siding, then this is very easily able to do. And we've got something to nail to on those. And the siding, of course, is nailed into those as well. So this is, the best way because we're getting maximum insulation out of there. And that's the whole point of advanced framing is to, so that we can get rid of these and get more of this. So that's the whole point in advanced framing.
Are more and more contractors learning these techniques and
You'll find out that probably, I'm going to guess, say 80%, we'll say 80% of the contractors are kind of stuck in their way. They don't want to do, they don't want to do new techniques. They, especially like the guy that I do some drawings for, I asked him flat out, are you using any of these techniques? No. Well, why not? Because it costs me money. I know what I know. As a matter of fact, CAD, for God's sakes. Okay, so this man, you would not believe. Let me just show you right quick.
well, a lot of people aren't CAD literate.
Well, I mean, he is in CAD. He's in the CAD, and he is. I asked him the other day. I said, "What version? What 1960s version are you in CAD?" So, and of course, I'm probably going to find the one. Yeah, look at there. Okay, so this is the way that I note this. All right, so I'm using leader, and I put the leader in there. That way I can grab it, I can move it, right? This is the way that he does leaders. All right, he does this, and that, all individual.
The old way.
Yeah, I mean, he asked me, I said, well, let me teach you. Nah, I don't want to do it. Well, why not? Because I make money in my way and I know what I'm doing and I don't need to change my ways. And that is inherently what, we're dealing with contractors. Excuse me. Brian at Red Tree Builders is one of the few builders that I know of that I have come in contact with who embrace the new building techniques. And, he is getting, his houses are getting Energy Star LEED certification. That's the one that I was telling you about that tested a 0.17 blower door test. I mean, he's embracing these new techniques and he's profited from it because there are some people out there that look for contractors like this to save them money. Now, the people that seem to go to the contractor that I work for, they, here they are, they're retired from Florida and New York and Chicago, and there are two of them. They're already into their 70s and they're building a 4,000 square foot house that costs, $2 million. They could care less whether it saved them a dime on an energy bill. All they want is a house, and that's what he's building. So
And they probably drive SUVs also.
Oh, yeah, absolutely. Yep, yep, yep.
What you just explained is exactly why I'm moving back home, because this 3D and our Revit, I'll never be able to use it up here. These people stuck in the mud and in the, like you said, the 1960s. So I mean, I can't even use my degree. Back in my hometown, I know
Home.
modern.
Where is home?
Moore County, Pinehurst, Southern Pines, Aberdeen,
Okay, yeah. Mhm.
golf and horses.
Yeah, that's right. You told me that, yeah. Yeah, the bigger cities, the more progressive places, they're going to be more acceptive into stuff like this. And, you know, really, Buncombe County, if you look at a map, Buncombe County is blue surrounded by red. And so, you know, I'm not kicking the conservatives, but they seem to be more, you know, this is the way that I do it. This is the way that I make money, and I'm going to stick with it, and I'm not going to change type thing. So, you know,
Eric,
yes,
working in Atlanta, we estimated we had about 12 to 15% of all of the homes getting certified Energy Star and Earthcraft House. That's still a very small number, but it's a much bigger number when you figure 12% of the Atlanta housing market. But 12 to 15% is still a very small number of the builders using those techniques. And on your point of people just being used to their ways, I had one builder try to go to 2x6 framing. So he had 2x6s delivered on site, but he didn't communicate that to his framers so well. So he put they all put 2x6s on 16-inch centers and ran out of wood. That house cost him a little bit extra.
Yeah, communication is huge. Well, you know, it goes right, but you know, it's not only the contractors. You know, we've got to get out there and educate the carpenters. You know, and I guess the carpenters are probably worse than the contractors as far as, well, that's the way my grandpa did it, and that's the way I'm going to do it. You know, so
Change is hard for some people.
what is it?
Change is hard.
It is. Yeah, change is very hard. I'm one of them. You know, I mean, I like what I do, but you know, I have to, as an educator, I have to keep my eyes open to the new way, to the you know, the way that it, you know, what's up and coming. And you know, when I teach, so here I am, I'm teaching, and you guys are going to be going through this, maybe finishing up in 2 years, if you know, if all goes to plan. What jobs, you know, I've got to look ahead. What jobs are going to be out there in 2 years for you guys to take? So I got to teach you for jobs that may not exist. So, you know, for me, it's really hard. But yeah, so you know, you said 10 to 15% in Atlanta, Danny.
I think he said 12 to 15.
12 to 15. Okay. So I was,
yeah, we estimated 12 to 15% of the houses being built.
Okay, so
we're getting certified.
We're talking roughly 75% of the builders out there are still stuck in the old way of building, correct?
Yeah, 75 to 85% of the builders. And you know, Atlanta's Home Building Association does a lot to try to encourage guys, and they offer all the classes for free and everything, but not a lot of people taking it up.
Yeah. Yeah, see, that's another thing. You know, I've seen a lot of the new green building stuff, and you know, they offer classes, but to offer them for free is really, you know, a community coming together to try to change for the better in the future. And there's a lot of these companies that are creating, you know, these classes. And I'm obviously in the wrong, you know, I'm in the wrong business, because I need to be doing my own thing and charging you guys like what, $500 for a 3-day session. I mean, Jesus, Pete. Some of these companies out there are, you know, raking it in. And the funny thing is, you know, contractors now have to have CEUs, architects have to have CEUs, engineers have to have CEUs, and that's a continuing education unit. So they are required to take classes, and you know, a lot of them don't have the time to set in, a 16-week program like you guys are going through now. So they take this weekend deal and they pay out the yin yang for classes. So it's kind of sad. Okay, so here's that connector plate that I was talking about, using in corners instead of a double top plate. Remember that you've got to stack all your lumber. So in here, let's see, let me go down here into page, and you guys can now download this as well.
Got it.
Okay.
Anything that's downloadable, I always go get it.
Yeah. So, they're talking about 24-inch grids and stacking it. So everything is, stackable right on top of, so we've got, floor joists, studs, trusses, everything is stacked in a perfect line. And it takes a lot of thinking to do this. You're talking about buying the 2x6s and put them at 16 inches on the center. I was working for a contractor one time, and so we were laying out a building. Let me get rid of this little screen right quick that you guys can't see. And it was, it was kind of saddening. So I was the job super. So they laid off the floor joists from this side working in that direction. And they were 2 foot on center. And son of a gun, when they started laying off the joists, they laid off in that direction.
2x8s or 2x10s?
What's that?
Were they 2x8s or 10s, or what were they?
I don't remember. Just these were the floor joists, and they laid them off from left to right. But then when they went up to do the studs, they laid them off from right to left, which means the studs did not line up completely on top of the floor joists. And, you've got to make some rules when you're doing these type of things to ensure that you're going to get these laid off in the right direction. So we could have went with a single top plate on here, but because they shifted these however far, I don't remember, they shifted these and they didn't fall in line. The studs didn't fall in line with the floor joists. Now we had to use a double top plate so that, that everything worked out correctly. Even if this was, down on the floor and we got the trusses perfect like this, because these were off, the building inspector would not accept a single top plate. He made us put up a double top plate, even though, we went back with the trusses perfect, but he wouldn't go with it because it missed that criteria at the floor joist. And I know that kind of sounds silly, but when I say, ground rules, and so this was something that I always made sure that all my guys knew about. Everybody did the same thing. We always, if you're looking at the floor plan and this is the front and this is the back, everything went right to left, or excuse me, left to right as you were reading, and from front to back. So even interior walls, they always used the, left to right, front to back, always. And that way, all of our studs, if you stood over here and you looked in there, then, basically all of these walls, even in the centers here, should have lined up. You should see one stud down through there instead of a whole bunch of studs that's not laid up. And again, it's, people get on the job site and they just go at it, and it's kind of like a bull in a china shop. They don't pay super attention. They're thinking one stud at a time, and that's, I've always told people, when you're building a house, they think, oh, it's overwhelming. How in the world do you ever build a house? Well, it takes one board and one nail at a time to build it, and that's what you think about. But you've got to, you've got to envision the entire scope of the finished product as you're building it. And a lot of, you have to, it's just a lot of looking ahead. And I'm finding this out with my bus because my wife, she doesn't see this. And she's thinking, oh, I want to see walls and I want to see, and we went to Lowe's and she's picking out sinks and colors and all of this. But, I brought her in here and I set her down and I said, you see all them scriggly lines in there? All of this red and yellow and green lines, all of that's got to go in before we think about paint. And that's just the electrical. Here's the plumbing. All of that has to go in before I can cover up the ceiling. And I mean, she's planing, she's been, she spent the weekend planing and painting or staining the roof ceiling. And I can't do any of that until I get all of this pipe and all of these wires up in the ceiling. So, there's no difference in a house. You've got to get everything, you've got to look at it as a whole, even though you're looking at it as at an individual thing.
Quick question.
Yep.
Do you know if in the modern times, if architects are required to take any kind of construction or framing classes? Because I've noticed just scouring the internet, looking at floor plans and like, none of the walls line up. I'm like, that's a framer's nightmare and so impractical. Like these architects are retarded. They don't even think like that. I mean,
Well,
it's
unfortunately, when, so my plan, I had planned to go to UNC Charlotte and become an architect. That was my goal when I was in middle school. So, and it really, it's kind of sad that our guidance counselors, they are not trained. They don't know. They know a little bit about everything, but they don't know a whole lot about nothing. So, they all say, oh, you need to take drafting. You take drafting. So, from 9th grade all the way to the 12th grade, I did nothing but drafting. How many art classes did I have? Absolutely none. So when I went to UNC Charlotte and applied, I took my portfolio of all my drafting stuff down there and I thought, great. Sorry, I got into the school, but I couldn't get into the School of Architecture because I had absolutely no art. So when you think about architects, they are, they're down here with their little pens and they're thinking, ooh, look at that. That's a great roof. I love that roof. That's perfect roof. And we'll put, we'll make it over here where this is all glass. And it's everybody, it'll look so cool. And the sun's going to be shining here and there's going to be lots of light. And then when they build the damn thing, you've basically created an oven and nobody can survive in it. It goes back to even Frank Lloyd Wright, Falling Water, which is, a very, very popular house that was designed by Frank Lloyd Wright. So, it's gorgeous. It is uninhabitable. Nobody can live in this house because of the roar of this waterfall 24/7, 365. The glass house in Pennsylvania, I think it is.
architects are dreamers and artists. They're not engineers and they should be trained better.
Yeah. So the glass house. So, this is another one it's beautiful. It's great. It's in, plenty of light, but when it snows, everybody is inside sitting right beside a fire and they're freezing because they're surrounded by, what looks to be cold, wet weather. And it's just inhabitable, very inhabitable. So, architects are not necessarily instructed on how to frame nothing, as far as the CEUs, there's nothing that specifies the CEUs. They just go take the CEUs. So, I mean, okay, so my wife is deaf. We went to Denny's to eat Saturday. My wife cannot sit here and us communicate because the sun's coming in and blinding her all the time. All right. You know, it's just, it ain't happening. And so you can kind of get an idea of, you know, what if the sun was setting here and, you know, you're trying to look at something, you're trying to see TV, it just don't work. So yeah, it's architects need, they definitely should have to, you know, be.
They need to know how to design what that's going to be built.
What's that?
You need to understand how to design what's going to be built from a practical point of view.
Yeah. Yeah. And then, you know,
Well, it's kind of like left brain, right brain. Engineers are left brain, architects are right brain, but you need to merge them. I mean, they both need a little bit of each.
I agree with you. But, you know, it goes back to the contractors and the carpenters too. Everybody has to be on that mental guideline. They, you know, we can't have it being designed. Well, it's kind of like what Danny was saying. I mean, you know, the contractor was, you know, he was on board with 2x6s at 24 inches on center, but his carpenters had no clue what he was doing. So, you know, all the way down the line from an architect all the way to, you know, the floor person, the painter, they all need to be educated in some of this, you know.
Plumbers and electricians, HVAC, anybody that touches it needs to be on the same page.
Yeah. Yeah. So let me ask you a question. What goes in a house first, HVAC, plumbing, or electrical?
Plumbing, you got to set up first because it has to come through the foundation usually.
Okay. All right. So let's say that that's already done and you've got your framing in and you're ready for rough in HVAC, rough in plumbing, rough in electrical. Which one comes first?
Are the studs up without drywall on them?
Yes.
So the wire, okay, I'm a little confused. Is you said roughing, so the wire's roughed in with box?
No. We've got framing. That's all we've got. The framing is up, the roof is on, sheathing is on the outside of the house. There's we might have doors and windows in. It's you know, it's weathered, and we have just open studs on the inside of the house.
Electrical.
Electrical, why is that?
Well, I mean, you got to run everything before any drywall goes up. So you got to drill through the studs to run the wiring, and you got to go up, over and down. I mean, that's how they did it at mobile home, but I've seen a lot of houses built. Usually the electrical, and you put your boxes in because the drywall's got to be cut around it and all that.
Okay, so you're saying that the plumber comes in after the electrician and works around the wires.
Well, no, actually I said the plumbing, like whatever comes up through the comes up through the floor is got to be put in first. So I would say the plumbing's first and electrical and then HVAC last.
Okay, so think to yourself, what is the largest rigid material?
The ductwork for the HVAC.
Bingo. All right, so the HVAC ought to go in first, then the plumbing, and then the electrical last, because all those wires can go around everything else. So unfortunately, subcontractors, plumbers, electricians, and HVAC don't always see eye to eye, and they have their little, I don't know what you say, they
Idiosyncrasies.
What?
Idiosyncrasies.
To say
peculiarities.
To say the least. So I'm friends with the local building inspectors here, and they know that I'm an instructor, so that when they find weird stuff, they send me pictures and stuff, and I don't have the picture. I wish I did. So the HVAC guy was called, and then the plumber came in, and the plumber was pissed because the HVAC guy had been called first. They, this one particular HVAC and plumber, they had a long running problem with each other. So the HVAC guy intentionally ran some duct work where he knew the plumber would be using a through roof pipe. And then when the plumber came in, by God, he just cut a hole right in the middle of that ductwork and ran his pipe through the ductwork. So, you know, obviously it's not going to pass. Obviously it's going to cost them, but they're such a, you know, both are such a stubborn ass that neither one of them want to, you know, so they cause problems. And, you know, it's, you know, it's sad. It's very
Oh,
sad.
Jesus. That's about as redneck as you get.
Well, you know, I do speak Burkinese, but I don't, you know, I don't always live the Burke County, I'm trying to say, I don't, yeah, I don't, I might be a hick and I might be a hillbilly, but I ain't no damn redneck. So there you go. Okay, so let's talk about really advanced framing. How would you like to have to do something like this? So this is called alternating, I just lost it, alternating non-conductive framing, and it is a freaking nightmare. You think, you know, framing in, so these are actually put in at 24 inches, but they're offset. So you've got an inside and outside. These are 2x4s rather than 2x6s. So what this boils down to is there's no way for heat to, you know, to transfer through the wall. So when we have a change colors here. When we have a regular wall, you know, we have to think about heat conducting through here through the stud, right? So this is completely open so that we don't have any of the inside touching the outside except for the top and bottom plates. But look at this, top and bottom plates can be as big as a 2x12. I don't know about you, but have you priced a 2x12 lately? I mean, the damn 2x4s are 7 something. So, you know, this is rough. This is, you know, this is serious right here. So basically what that does is that puts insulation, you know, between the walls and the studs. So there's no transfer of heat through there at all. Did I talk about the rain screen here?
The what?
Rain screen?
No, no.
So the rain screen is another way to keep air flowing through here so that we keep moisture down. And so this is basically a stripping. Let me find a better picture. I know I've got one. Let me go over here and open up.
That method may be expensive, but it'd also be good for soundproofing too.
Yeah, well, that is exactly the way you soundproof a house.
Yeah, you could be next to an interstate and you'd never hear anything with those thick walls.
It's possible. But now keep in mind that, you know, as a whole, you know how a speaker works. If you get the whole wall vibrating, then it's going to be a great big speaker.
Yep.
I'm sorry, this is not what I wanted to open. Let me back up. Rough night.
Actually, I slept well. I don't know why I'm yawning. You know, next week is spring break.
Yes.
What are you trying to find?
I'm trying to find that PowerPoint, but it's I don't know why I can't.
Is that the one you gave us that you uploaded?
Did I?
Well, I don't know. Which PowerPoint are you referring to?
The one on maybe it's that one. No, not that one. That's one I just put on there.
Got air sealing, building envelope.
No, that wasn't it. No.
The only one I show right
Back
now.
over here to building science.
Oh, wait a minute.
Why I can't download stuff that I can upload all day long, but I can't download stuff for some reason. Where's my links?
Yes.
There.
Is it something you went over already?
Yeah, I just want to kind of go back and refresh your memory.
You must not have uploaded it for us.
I didn't, and I need to. Any wonder why my computer crashes all the time? Everything's open.
You said it's a new one, right?
Knew what?
Computer.
Fairly, yeah. Less than a year.
How much RAM you got? 16 or 32?
No clue. Don't know. Okay, so there's the picture that I was trying to reach. And so what's going on in here is we've put our house wrap on, and then we went back with furring strips across through here, about a half by 1.5 furring strip. And then our siding goes on top of that. What happens is with this type of siding, water will sometimes get forced up in behind this, like on a foggy day or maybe some rain, a wind-driven rain or something like that. Water gets up behind this. This is going to happen all the time, and that's why we put this house wrap on, is to prevent that bulk moisture from getting pushed into the building. However, this house wrap works kind of like Gore-Tex material, where it will allow for vapors. It'll stop the bulk moisture, but it allows for vapor air or vapor moisture to be sucked out of it, like on a warm day. So by doing these strips, we're creating a rain screen, which means that if any bulk moisture gets up under the siding and against the house wrap, then it can run down and out across the bottom. Now, when we get down here on the bottom, basically what we do is we just we can attach a piece of screen, and let me go back and show you this.
Well, hopefully that siding is caulked so it's air and moisture tight.
Well, you'd think, yeah. So here is the wall. Here is our furring strips. And then here is the siding that's on there. I'm going to do a crude drawing so that I can get through this. And down here at the bottom, basically what we're going to do is we're going to take some screen wire, we're going to loop it around, and we're going to staple it into the bottom of it. So this prevents any kind of vermin from getting up in here and building homes and so forth, but allows for any moisture that gets in here can drain down in this thing. And I have also seen these where they're vented across the top so that you actually get movement of air between these to absolutely just dry up any loose moisture that you have in there. So this is, these are a good idea, but they're kind of a nightmare to build. Number one, if you're using extruded polystyrene behind this rather than plywood or OSB sheathing, then you've got to make sure that these are right on top of the stud that's in the wall. And then one thing that personally that I've had is I've had a problem with the damn thing's busted. So, okay, I'm looking down on this portion here. Here is my, we'll just draw the studs and everything. Here's my stud wall. Got my studs in there.
2x4?
Either. And then I'm going to use extruded polystyrene on here so that I get maximum insulation through here. Then I'm going to put these strips on there. So again, they're like a half an inch thick by 1.5 inch wide. And I'm going to nail these on here with my framing nailer. Because they're a 1/2 inch, I could stand a problem of them splitting. And that's what I've had a problem with. And then I'm going to put my siding on there, and I'm going to nail it on as well. So now I have 2 nails going through a very thin piece of wood, and it stands a better chance of busting. Now, if I can get it on and, you know, everything's okay, hopefully I can get away from the job site before it falls off, right? No, I want to make sure that I do a bang up job on this. And so, you know, care has to be really taken when putting these things up. And I have, just me personally, I have found that nailing them by hand is the best way, rather than a nail gun, because a nail gun is going to shoot it in there and they don't give a flip about it. And so I've just had a lot of problems with them busting with a nail gun. So
That's a lot of pressure.
yeah.
What about staples, like the thin, what they
Crown
call?
staples, yeah, you could do crown staples. Yep. That would probably work better. I didn't think about it, but only because the only reason I didn't think about it is because I don't have one. I don't have a crown stapler. So
Oh, that's a good investment.
yeah, it is. It is. Okay, so now let's make sure that
Hmm.
all right. So advanced framing a little further. So this is, you know, kind of where we're talking about where the architect comes into play. Actually, it is where the architect comes into play, or draftsman. Don't want to leave myself out of it. So let's build a house. All right. So, you know, well, for one, this is a house that typically, you know, that most, I don't know about most, but I would say, you know, some people want this. An architect, you know, this is the floor plan of a house that an architect's going to design, you know. So, you know, they're not thinking about material. So we have been talking about 20, let's call it 24 inches on center spacing. So why not design the house around 24 inches? So instead of having, I mean, you know, crazy shit like 67 feet, no, not even that. We'll make it 67 feet, 5 inches, where you're going to lose a whole bunch of material. You know, let's make it 40 feet, period. All right. By 20 feet, period. All right. So that's kind of small, but anyway, so when we go to put our plywood in here, then, you know, we're using whole sheets, and we've designed it to where when we use half sheets, so we basically offset these. You know, we'll start off with a full sheet, and then we have a half sheet, and then we're going to have another full sheet. And then we're going to go back to a half sheet. Make sure that this house is designed to where we don't have a quarter of a piece, or we have we have to a little bit hanging off here, and we got to get rid of 6 inches. And, you know, it's just a pain in the butt to have to cut plywood more than than we have to in a full sheet and a half sheet. So, you know, here we've got 4 sheets. Well, guess what? Right here, we've got 4 sheets. We've took half of it over here and half of it over here, back to four full sheets. And then we're going to use the half and the half here. All right. So when we're designing that house, really, we need to be looking at a half sheet of plywood. So we're talking about 48 inches by 48 inches. And if we have to cut our plywood any more than that, then, you know, we're kind of spinning our wheels when we're talking about this. Well, the same is to be said about our roof as well. You know, if we can design the house plan to be utilized to where we have a perfect usage of the plywood here, then when we get to the roof and we design it so that it uses, you know, perfect sheets of plywood as well, then we don't have any waste. All right, less waste. One of the things that always came to my mind when I'm talking about waste is, you guys know who Norm Abram is?
I know that name. I know I've heard it, but I forget who he is.
That this old house?
Well, he started out this old house, and then he went to the New Yankee Workshop, right? He started.
Oh, yeah.
So
I remember.
why was he hired? Well, one of the reasons was this: the producer was going around, and he was trying to find, contractors that would be willing to do a show. All right, so this old house. So Norm Abram, along with that other guy, and I can't think of his name right offhand, who sold Sears tools for a long time. They were the runners of this old house.
Bob Vila.
Bob Vila. There you go. So why was Norm Abram picked? Because his job site had little to no waste whatsoever. From what I read, there was less than 3 inches of plywood thrown away, and less than 6 inches of any stud or dimensional lumber that was thrown away on his job sites. So he got the job because he had less waste on his job site. So he was, obviously he was pretty conscious as to, the material cost, the material usage. Because for years, this material has cost us absolutely nothing, really. When I first went into business in 1984, a stud cost me 81 cents, if I remember correctly. And today there's at Lowe's yesterday, they were $7.42, I think they were. A stud, not even a 2x4x8, a stud. So, using this and trying to, utilize the most material with less waste is another key. Now, keep in mind, all of this stuff that I'm talking about here is, that gives you brownie points, I guess you could say, with the LEED technology or the LEED certification stuff. So all of this that we've talked about is leading up to the LEED stuff. So keep that in mind as well.
Leading up to the lead.
Up to the LEED.
Oh, I was, yeah, if you went as small as a 2-foot base increment, you would pretty much, and I never thought about it. So now the slope is usually determined by, if you want to live in it or not, but hell, you should use this method to determine the slope, not the other way around.
What do you mean the slope? The slope of the roof?
Yeah.
Oh, okay. Yeah.
Because it's a direct component that.
Well, that's exactly what I'm trying to teach you guys. Yes, you're absolutely right. So if we went, if we just decided we were going to do a 6 and 12 pitch, okay, we're going to do a 6 and 12 pitch, and it's going to take 3.5, or we'll say it's going to take 30.5 sheets. But if we moved it to 7 and 12, it's going to take 32 sheets. So do we want to buy a whole extra sheet, or do we want to throw away half a sheet? So, that kind of thing is some of the things that you have to look at when you're designing that, for sure. And,
I'm gonna start doing that.
Also, let's think about our
walls.
let's think about our overhang. Okay, how big is this overhang?
Should be 24, because that's
in the northern states, we want this as small as possible. All right, because we don't want to have any ice dams and stuff on here. But maybe we want we want to be able to cover in the south here. We can have big overhangs, so that if we have windows down here, then we can use that overhang to cover this window in the summertime, so that we don't have heat gain in there. However, to determine this, why not go back to this piece of plywood here? We can get two pieces out of it at 24 inches on center. We can get 3 pieces at 16 inches on center.
Mm-hmm.
All right. I think my computer just froze. This is the overhangs that I'm required to do on this house. Is that, can that be, can you get that out of a piece of plywood?
18, well, not without waste.
Exactly. Why not make that 1'4"? I don't know. You know, I don't argue with him. He pays what I do, and I just do the drafting and keep my mouth shut. You know, and especially stuff like this, you know, what the hell is that? Well, it's stuff that looks pretty. It's stuff that sells, you know, so it's just an overhang, an extra overhang to give it some more oomph.
Pizzazz.
What?
Pizzazz.
Yeah,
In jewelry, they call it bling.
Yeah, well, that's bling, yes, for sure. So, you know, that's what you're dealing with, you know, so anyway, that's what you should be trying to do, is get your maximum usage out of a piece of plywood. And the plywood is a lot of times what should be used to design by, you know.
You just made me realize something too, that
4x8.
you've got to consider your overhang and your roof slope at the same time. Otherwise, one or the other is going to throw you off and you still have waste. So
Yeah, well, you know, it's not always a question of using 100% of the piece of plywood, but if we can use 95%, it's a hell of a sight better than using 40%. Okay, so, you know, we're shooting for this, but we're okay with that.
Oh, yeah.
So, you know, we're not trying to get 100% absolute total out of that.
Well, my OCD perfectionism will.
Yeah.
Well, on the computer, it's easy to figure
Oh, yeah,
out.
it's easy to do. Well, I mean, you know, CAD, in my earlier days when we, you know, we actually had to have a calculator. Can you believe that? We had to have a calculator to determine all of these numbers. We had to sit here and count all of these up to see if they came up to 36 feet. So, you know, hell, nowadays we just slap it on there and don't even think nothing about it. What we're worried about is actually getting it. For instance, if I'm doing a measurement now, you know, if I'm trying to get to this wall here, just make sure that I don't miss it like that, and I come up with some crazy dimension on there. So, and another, I don't know. So are you in the architectural degree or architectural certificate program?
Me? No,
Yeah.
I'm in the 3D CAD technology 2-year degree.
Well, did you take any architectural drawing stuff?
Oh, hell yeah. I took it under John.
Okay. So what is the smallest increment that you design to in a house?
Well, which aspect? What are you referring to?
Okay. So when I'm going to lay out this house here.
You mean the room size?
I mean, room size, you know, placement of walls, you know, do you, so for instance,
I try to stay within 6 inches myself personally, but I learned all this before I took his class.
Right.
Nothing less than 6 inches. But I try to stay on a 1 foot or even a 2 foot grid because of drywall.
Okay. Well, maybe I'm missing what I'm trying to ask. Okay,
I put all the odd dimensions in the closets and halls.
So, you know, when we're building, when we're building, we're working to 3.5 inch and 5.5 inch. A 2x4 and a 2x6 have that 1/2 inch on there. So when we're placing walls, if I come up with a dimension of 4'3" 3/8 or 4'3" 1/16, I'm going to move that wall so that a 1/2 inch is the smallest increment that I have. And if you look at anything on this, you're not going to see any dimension, even on the first floor plan, you're not going to see any dimension less than a 1/2 inch.
I agree with you, but I try to factor in the finished product with drywall or whatever. So I'm figuring either a 5 inch or a 6 inch wall. I actually did a drawing with a 6 inch wall in his class. and realized, well, that's not reality. I had to go back and redo the whole damn thing over with a 5-inch wall so I could get my inside dimensions the way I wanted them.
Okay, how are you getting a 5-inch wall?
3.5, and then 2 5/8 drywall. I think well, can you still get 3/4 inch drywall or not? I know that you
Yeah,
could.
you can, but you don't need it. Why would you put 5/8 inch in on a house?
Well, I mean, that was common a long time ago. I guess they've gone back down to a 1/2 inch now, but it was pretty common a couple decades ago.
Well, if I have a 3.5 inch stud and I add a 1/2 inch of plywood, or excuse me, drywall on either side, then I end up with 4.5 inches. So it's almost impossible to get rid of that 1/2 inch because we're working with 3.5 and 5.5. So if I had 3.5 inches and I had 5/8 inch drywall
Yeah, it leaves you.
on either side, then I end up with, 3 3/4. So all I'm saying is, try to, whenever you're doing anything, when you're laying out for the centers of your windows, for the centers of your doors, for in between, in the old days, we used to dimension to the center of the inside wall, which always ended up with 1/4 inch or 3/4 inch. But with CAD, you can't just come over here and grab the center of that wall because it's not going to give it to you. So we have changed over to doing side to or face of wall to face of wall. And these are, this is not including any kind of finish on it whatsoever, because when the framer gets in there, he's going to, he's got a 2x4 in his hand. And so that's the dimensions that are going to be for him. And I just realized that.
Well, you almost have to dimension the center for a frame or it won't come out right.
What you mean? Center of what?
The center of the stud.
How's it not going to come out right?
Well, like we're calculating the finish, which is the 2 1/2 inch pieces of drywall, which makes it 4.5. Well, if you dimensioned it on a 4.5 wall, if the framer went by the face to face, it'd be wrong. You got to dimension to the center to place the stud where it actually needs to go, because then you got the 1/2 inch on either side.
Well, that's what I'm saying. I mean, if this is the stud,
now is that a 4.5 inch or is 3.5?
that's 3.5. We don't put any. I'm not going to put any.
So you put a finish wall in. You always do a stud wall.
Well, that's because that's what the that's what the contract, that's what the carpenter is going to be framing. He's going to be, he's got to put the studs in before he puts any finishing on. So if I were to dimension with, let's say for instance, I put a 1/2 inch sheetrock on this side and I put a 1/4 inch piece of paneling on this side, and then the homeowner comes in and changes that. Well, I would never I would never dimension this to the finish, because this way I can put any finish I want to on there. It don't matter if it's 6 inches of finish. I have my stud in place, and that's what the carpenter is going to start with. He's going to start with the stud. And the same carpenter may not even he may not even be putting in the finish. He may not, and maybe he's just a good old boy framer. He goes in there and does the frame, and he don't come back and put drywall and
drywall is usually done by a different discipline.
Yeah, so we want to make sure that we dimension to our framing and not to any finish whatsoever. But my point is, try to reduce that down to a 1/2 inch. Don't get any 8ths, don't get any 16ths, nothing.
Oh yeah.
Halves or holes, that's it. Halves or holes.
So all your floor plans are designed from a framing perspective, because when you look at a plan, well, architecture teaches you to draw with a finished wall. So that's why you either have 5 inch or 6 inch, I mean, that's typically what we've always used. So I haven't seen anybody do it this way, because You're coming at it from a more practical aspect.
Okay. Well, like I say, this is the first thing that's going to be put in place. You know, when we go and build, we're going to be putting these studs up before we put any finish inside or out. So the stud is the, you know, it's the centerpiece. It's the backbone. Let's just say it that way. It's the backbone of everything, because without it, the finish is not going to stand up.
That's what's nice about Revit. It does it automatically. I mean,
Yeah.
it's AutoCAD, you got to think about it.
You gotta
I might
think.
start doing it that way and just add the finish later, but I still want to have nice whole numbers between wall faces, like for drywall. You know?
Yeah, yeah. Okay, so insulated headers. If any of you follow the Journal of Light Construction, they have a great site and a great magazine, and I use a lot of their articles and stuff in what I teach. And I like it because they have debatable points on here, such as, you know, insulating that header. Well, which is better to insulate? Put the foam on the outside or put the foam on the inside? So to kind of back up and explain this. So in the old days, if we had a wall that was using a header, we would use the building code to size this. All right, so let's say that we're using a 2x4 stud wall, and it calls for the span calls for two 2x10s to be used. So if you know, and this was what I was taught when I was first in school, and this was, you know, this had you know, absolutely no pre-thought design in this at all. So my instructor said to build a proper header, because these are 1.5 inches, then if I were to put 2 of these together, that would be 3. Well, this is 3.5 inches. So what do you do with that other 1/2 inch? Well, you take a piece of plywood and you stick in there. That's what I was taught. Not going to lie you, to take up that space. All right. So you nail or screw all of this together and it becomes one great big heavy duty unit. And it used to be in the code book, and it's not, I don't think it is any longer. They would actually count this 1/2 inch piece of plywood. So if, you know, if you used just just two 2x10s, then it would do, you know, it would span an X feet and inches. But if you added a 1/2 inch piece of plywood, then, you know, you could do the X plus 4 inches, because they would actually add that in to the span carried.
Only 4 inches? You think you go further?
I'm pulling this out of my ass. I don't know. It's been a long time since I've looked that up. So it could have been a whole 1.5 feet more. I don't know. I'm just using this as an example. They don't do that anymore. So, you know, when we talk about you know, lengthening these, this is now steel. All right. So you can use a flitch beam, which is just you know, a 1/2 inch piece of steel and it adds, you know, many feet to this. However, we stand the problem of heat transfer through conduction massively, okay, because everything's touching out through here. So it became kind of a secondary practice for us to do, you know, if the code called for 2x10s, we'd put the 2 2x10s together, and then we would put blue board between it. And I keep calling it blue board because, and it's green and pink and all kinds of colors. Now it's extruded polystyrene. And, you know, when it was all blue, it was Dow extruded polystyrene, and it was blue board, about the color of this pen actually here. And so we would put that in there. And then of course we would sandwich that together, you know, and we thought, oh man, we're good to go. I mean, yeah, it put in a thermal break here so that, you know, when we had heat transfer, it hit this point here and it's pretty much stopped. So we've got to put in even further thinking, and that's where this site here decided that, or the Journal of Light Construction, they do these debates. And so, okay, so better building performance, insulation to the exterior, the rigid foam keeps the outside, keeps heater, what am I trying to say? 2 inches of foam on the outside keeps header warm. Okay, we keep this header warm. We have a 1/2-inch airspace in there. I don't know why we have the 1/2-inch airspace, but you know, what benefits does it have? Well, let's go over here and look at this. So if we put the insulation on the inside, then, you know, maybe we catch some water in here, because this is, you know, this has a very, very low perm rating on it. And anytime you have a surface touching a surface and water condenses in there, it stays. Remember that, you know, we talked about the ink quill pen, I think it was maybe in here. I can't remember if my classes are starting to get kind of blurry now. So, you know, it's going to stay there, and to get rid of it, then how do we do so? So it has always been, I have always been taught that no matter what you're insulating, you always keep the insulation to the inside. All right. So, you know, if you're going to have an airspace somewhere, that airspace needs to be on the outside, because you need to always keep your insulation touching on the inside. So that is like the #1 rule. And by doing this, then we're allowing moisture to come in here, condensate in there, and then we can possibly get some rot in this header. Why not split it apart? Same reason. If we were to put this over here, then condensation is going to get through this wood, because wood is porous, and it's going to settle in between the headers, and could possibly actually rot both of them rather than just one. So the preferred method is having the foam to the outside and keeping the header warm, as well as the rest of the room and everything.
Question, would you ever put the 1/2-inch gap between the foam and the 2x4?
Well, again, you know, it is inherent that we try to keep the, you know, put this up for you, Blondie. So it's, you know, we want to keep all of our insulation to the inside as much as possible. So by moving this air gap over here, then you're pushing the insulation to the outside. Even if we're, you know, doing we had our insulation out here and having our gap here, then we're allowing for, you know, condensation to get stuck in there, and we don't want that to happen.
So you want your vapor barrier on the outside?
No.
I mean, not vapor, your air pocket or whatever
you want. You want to keep as much of the wall warm. Let's say it that way.
Well, the space is on the outside the way they're showing it.
What's that?
The airspace is on the outside. That's where you want it.
Yeah.
Okay.
That's why they're saying it. Yeah.
Yeah.
Yeah. Let's see if it says anything about the airspace. I don't know. Let's see. Most builders use 2.5. Okay. So yeah. So if we're using if this is 2x6 wall, they're going to use a 2-inch rigid foam in here. Now we could go back and put a 1/2 inch in there. But if, you know, they're not doing that, they're not going to put that extra 1/2 inch in there. I don't know why. If I was really being super energy conscious, I'd probably put that extra 1/2 inch in there. I don't know that the airspace in this particular instance would benefit us whatsoever. It'd probably benefit us to put more insulation in there, because we're going to try to stop that, you know, that bulk moisture from coming in at this point during our house wrap. Make sense?
Yep. There's mud.
Clear as mud. I don't know about y'all, but the pollen is starting to build up. I've been.
Oh, it's already hit you?
Yeah. Yeah, the maple blooms. You got to remember, we're probably a week earlier than you guys.
Oh. It's not bad here yet.
Make sure that I'm not missing anything. Did I talk about raised heel trusses or knee walls?
Yeah, we've touched on it a couple times.
Okay. All right. Well, I don't want to sound like a broken record. All right. That is, and that's all I'm gonna say about that.
Okay, Forrest.
All right, so that is we're good. I think. Let me check. Again, make sure that you look through this down here at the bottom. I want to show you this checklist. Very, very good checklist. It's actually a rubric. It's a building rubric, and this is something that LEED uses as well. And a lot of these probably cross over. Well, let's do it this way. There. So a rubric. If you're not familiar with rubric, then a rubric sets up different standards so that you can end up getting a better score and stuff. So let me go down here to, okay. So we've talked about the footprint size. So in this first column, you get no points, 1 point, 2 point, 3 points. So in the rubric, when we're looking at this odd dimensions, okay. So, odd dimensions, that means, we've got some weird stuff going on there, 3 inches, 7 inches. And so that's not going to get us any points at all. And that is, look at that, standard construction. Okay. And that's what we've been kind of talking about in here. Standard construction is a tunnel vision type construction. You just get it done, get it on, move on with it. Light green construction, you have smart sizing, even dimensions in 2 foot increments. Then you go to medium green construction, smart sizing with footprint divisible by 32. And then you have dark green construction, which means smart sizing with footprint divisible by 32, long axis of building running east and west. And that's something I didn't talk about, running east and west, 2-story construction.
That floor plan, we're referencing floor plan when it has footprint size, is that what it's for?
Yeah. Footprint size. So, if we're talking, how big is this footprint?
Like you just described.
Yeah. I'm kind of confused, and I got to read on this. Why would they want to be divisible by 32 rather than
Plywood?
So
332s is a piece of plywood, long ways, that is.
Okay, yeah. True. So that's even, yeah, you're absolutely right. But at this point, you got to think about the plywood. Will the plywood span that? And you're going to have to check your span, your plywood. Let me pull that up real quick.
Oh, you mean 32 inches on center? Well, can you do that?
Plywood.
Well, you probably got to have a 2x10 or 2x12 to do it with, don't you?
Plywood. I don't know why I always want to say plywood instead of plywood. Plywood span rating. So when you're looking at your plywood, you've got to look at this, you know, you got to look at this span right here. And so, you know, when this plywood is rated, it is rated to be run with the grain. And I think I've talked about that as well. When you're talking about plywood, you have an odd number of plies and the grain on the inside and outside run in this direction. Okay. So when you're looking at this rating here, 24 inches on center, that means that it will only span 24 inches there. We can't get a max. That's our maximum span is 24 inches, and that's a sturdy floor. So we're talking about, all right, notice that the thickness, this always gets me. The thickness, is it 3/4 of an inch? It's 0.703. So I'm just gonna check something right quick.
A little more than 5/8.
703 inches.
Actually, it's 9/16.
It is,
That's close to
it's closer to 18 millimeters.
Well, we don't
All
think
right. And so when you're looking for plywood, remember that the United States is the oddball. And most of the machines that we use are built outside of the United States where everything is millimeter. And so these are just as close as we can get to the millimeter and show it in inches. So, you know, right there it is, 18 millimeter exterior. And that's what is actually, that's the actual, this is the imperial standard equivalent. All right. So sheathing is a different story. Sheathing goes up and down vertically, so you don't have any weight being pressed down on it. The only thing you have to deal with there is wind loads and so forth. So you couldn't use, you know, we still can't do 32 inches on center. And like I say, that's, you know, you'd have to have pretty good, you might have to have an inch piece of plywood before you get to 32 inches on center on that. But anyway, so look through this checklist, and it is a very, very thorough, comprehensive type little rubric that you can use to build a house. And so you could get, different ratings on here, and you know, the higher the rating, the better. And then so you can, this is kind of like the way that LEED works. They use rubrics on that as well. It's a little bit more convoluted, but it works generally in the same principle. All right. What's that?
You give us that one? What's it called? Green Building Guide?
Yep. That's the one I just put on there.
Okay, yeah, I've had it.
I thought you said you already opened it.
Yeah, there it is.
All right. Any questions about advanced framing? Anybody think of anything that I have forgotten? I think I've covered it all.
We didn't mention much on the materials like truss, like engineered joists or finger joints. You know, a lot of people trying to reduce their lumber usage are going to go to a web truss or an eye truss or even finger joint studs now.
Yep. Okay. Very good. All right. So eye joist. So what is an eye joist? An eye joist is just that. It is a flooring member that we can, you know, we can make as long as we want, and it's an engineered floor joist that really is the way to go nowadays. But there's certain things that have to be taken into place when building this. Now, and when these originally come out, when these originally come out, you can see from this picture here, it had an OSB, and even before the OSB, it used plywood. When they very first came out, they used plywood, and then they used dimensional lumber across the top and the bottom. And so it's, these were good, and here's that finger joint that Danny's talking about there on this one. So we can make these as long as we need to. However, because of these finger joints here, these can actually add a weak point in it. So we switched over to, not that one, we switched over to LVLs. So, and this is, let me see about this. Yeah, I guess it is. We switched over to an LVL, and even though this is laying down, it really doesn't add a whole lot of structure to it because it's laying down, but we don't have a particular weak point in it. These can be, we can stop this layer here, 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 and we can end up with a continuous strong flange on this thing that has no particular one weak point on it. So these are designed to carry load in in a bending fashion. So when we're thinking about that, so we have, there's different loads that's going on. So we have compression, we have tension, we have bending, we have twisting, shear, and a whole bunch of others. But the one main thing that we deal with is this bending. So like I say, these are designed for the bending motion. So what happens if we have, that's not even the right one, doggone it. Well, I'm gonna go ahead and use this as an example.
How about the one in the middle? Is that it? The one over in the middle?
This?
Down, 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 right there.
Well, that's what I had a minute ago, but it doesn't show exactly what I'm wanting to, the point that I'm trying to get to here. That one does. Let me open up this. Okay, so these are designed for the bending. So, we can hold it over here on the end, we can hold it over here on the end, and we can put stuff in the middle of it. And these are designed for the bending motion. However, we stick a wall underneath it like this, then we prevent this from doing its flexing, moving thing. And what can happen, especially if there's another wall on top of this that might be bearing, then these are not designed for the compression, and they can crack right down the middle of it. So what happens is we have to go in here and we will put in what is known as a squash block. Let me move over to here where I can explain that a little better. So we have our eye joist, and let's say that we have a wall that's going to run underneath it, and then maybe we have a wall that's running perpendicular on top of it. So the weight from this wall pushing down can buckle this piece of OSB in here. So what we have to do is we have to take 2x4 pieces in here and just place them right up beside of it. And what happens is we're transferring that weight. That weight is coming down. Instead of going across here, it's going to transfer over and then on down and so forth, so that we don't, and this is called a squash block. Squash block. How you spell squash, Jim? It.
SQUASH.
Okay, squash block. All right, so that's just to transfer that space. Now, how long can these be? They can be forever long.
Okay,
Now, they not necessarily are going to span that long, but they can be put down as a single unit so that we don't have any lap joints. When I say a lap joint, say we've got a girder here and we got a joist coming in, and then we're going to lap it and continue it on the other side. This, those eliminate that. With an I joist, then we can just go all the way as long as we want to. All right. So how long can we buy them?
40?
An infinite. Now the question is, how long can you haul them down an interstate highway?
60?
53 feet.
53 feet is the maximum without a special permit. So, if we had a house that was 53 feet long, we can order these. Now, I'm not saying it's going to free span all this way, because if it did, it's probably going to be about 60 inches tall. So if we go over to a span chart, let me go pull it in the span chart. So if we're looking at a span chart, you can see that those come in different sizes. So when they're designing these, it could be any number of things. So in this particular design, we're 14, 16, 16, 16, 16. So we're trying to keep it within a unit that is workable. I mean, if we had this thing 3.5 inches wide and it's 4 foot tall, at some point, all we're doing is adding more dead weight to it, and it's going to lose its deflection in there. And we'd have to move on to something like a floor truss. And that seems to be, that's another thing that is becoming very popular nowadays, is floor trusses, because we have all this beautiful space that we can run electrical and plumbing and HVAC through. Whereas if we had these I joists, there are very certain rules as to where you can cut and where you can't cut.
Are they cost effective?
Absolutely. Absolutely.
And they're obviously prefab, so they're going to be stronger.
Yep.
I mean, that's not the word I'm looking for.
So you can only cut them so much, and you can't cut the flanges, the top flanges, or the lower flanges at all. So there's, this whole table here is designed to help you understand where you can cut and where you can't cut. So, by using a floor truss, it's just like a roof member. You can, and these are, these can be put 2 foot on center, and as well, and they work great. Matter of fact, the company that I draw for, if you'll notice, going back over here to there they are. First floor is done all in pre-engineered floor trusses. So that
what's the height on that?
1 foot 8 inches on those. But those, again, depending on your span, those could be different heights as well.
What's the boards running through them for?
What you mean?
The boards that are running perpendicular going through them.
You talking about here?
No, further over.
Here?
Yeah, what's that for?
Stability. That could be an LVL. So let's go back over here just a minute. So we actually use LVLs, and that's the way we keep it to 1 foot 8. If I were to do this whole span, 28 feet, without this LVL in the center of it, then this might be twice as big, twice as tall. So when I'm designing it, I'm going to go ahead and put some gang studs in there, and this doesn't show it, but there is an LVL. Why do I not show that LVL in there? Anyway, there is an LVL that runs down through here. Let me go. It runs down through there, and then when we do our calculations for our for our floor trusses, then we only have to basically do a dead load at 13.1 rather than doing a dead load at 26.10. So that way we get a smaller thing out of there. Now, if we didn't use a floor truss, we're probably going to have a whole, or an LVL, okay? And I'm going to talk about an LVL here in just a second. If we didn't have that, then we're probably got a whole bunch of posts down here, or we have to redesign this with a wall in the middle of it with a haunch slab. So that could be, this is also used to keep the trusses together upright. So it's a what am I trying to think of? It's a purlin. It's not a purlin. Anyway, it ties them all together. Strong back. Thank you. It's a strong back. A strong back.
Strong back. Okay.
Yep. Yeah, right there's the word right there. Strong back. Let me just go pull that one up. So a strong back is a method of putting a piece of wood in there to tie everything together. In a ceiling, when you're doing trusses, I really need to close some of these. When I'm doing a roof truss, you will see generally, and you'll see these in rafters as well. They'll take a 2x6 and put it onto a 2x4 in a lot of cases, and they nail these together, and you'll see them on both sides.
Oh yeah, I've seen that before.
Okay, that's a strong back. Basically, when you have a whole bunch of stuff in here, this comes in through the center of it and helps tie this all together so that they don't move back and forth. And like for instance, if somebody come up here and was walking through here, then it ties all of these together so that we have the weight being transferred across a greater spread of members rather than a single member.
I think they use that in mobile home construction because I used to stand on them when I was running wire up there.
It's possible, very well, could be. Okay, so LVLs are like a piece of plywood. So let me back up here just a second. So when we're talking about plywood, we are taking, a piece of veneer. Let me go a little bit further. We take a tree and it's turning like a lathe, and we have this big long blade that is peeling off a thin sheet, okay? And it's, we take it down, and this thing, what's left is about 6 inches, I think it is. And then we take these and we orient the grain. So in this first one, the grain's going to be running this way. And then we're going to put a second one on top of that, and the grain is going to be running this way. And then the third one is going to be running this way, and so forth, and so forth, and so forth, until we build up to the thickness that we need. And then we cap it back off with one going back in the same direction as our first one. Okay, remember I told you we have odd number of layers on there. So this is the way that plywood is built. So that way we have strength both in this direction and that direction. So that is plywood. So let's talk about an LVL. LXL, let's try LVL. So the same method is being used here. We're taking this tree and we're rotating it, and we're pulling off a big old piece of very thin wood, and we're going to put the first ply down in this direction, and we're going to put the second ply down in this direction, and we're going to put the third ply down in this direction, and so forth and so forth. And it doesn't really matter how many plies we have because they're all going in the same direction. So what does this give us? This gives us a huge, strong, bending motion beam. Okay, so you guys remember the difference between a beam and a post? A beam,
Horizontal,
nope,
no.
is under bending stress.
Oh, that's right.
A beam is under bending stress, and a post is under compression.
Compression, that's right.
Remember that. All right, so this is a beam. It is under bending motion, and we can make this as thick as we want, and we can make it as tall as we want, and we can make it as long as we want, up to 53 feet without it being permitted on DMV roads. Okay. So with that, we have discerned that we can do long tables on this. We can, we've tested this. We know what kind of glue is best. We know what kind of thicknesses is best versus what kind of heights is best. And we have, we can do LVL spans. I would not suggest using a generic span table at all, ever, such as this here. Never, never, never. Go to the site of whoever you buy it from. If you're going to buy them from LP, go by their technical guides, because they use different glues, they use different engineers, and they've had different testing methods on it. So, here is that LVL with an eye joist. So we're using the LVLs down here to help support these eye joists, or we can hang them on there. That, with that, then if we have,
Are there code minimums for a lot of that?
not for LVLs, the code actually goes in there and says, you're going to go by what the manufacturer says. So going back to this, the raw drawing here for just a minute, let it go through its thing. I'm sorry, guys, it's going to take a minute. This is a huge house, but I wanted to show you where LVLs have to be used. I mean, there's just nothing else that can be used other than steel. And it's going to take a minute. And I wish I could stop it in the middle of it. I just forget about it. And well, it's not going to open up. And it's froze. Okay, good. All right. Let's look at this here. I have an 18-foot wide garage door right here. So in this case, we're using a pre-engineered steel truss. The house that I'm doing this one for is actually a company. It's the owner of a company that they build these trusses here in Morganton. So obviously he's going to use his product. So, but if we were doing a wood house, how in the hell would we span 18 feet? We could use a steel truss. We could use a wooden truss, or we could, 18 feet, we could go in here and we could look down here, 18 feet span. So we're going to use a 3.5 inch wide beam or a 5.25 inch wide beam, depending on if we're using a 2x4 or 2x6 wall. And depending on the size of the house this way, and going back to that, I'm going to be using 24 feet. So under 24 feet, this is either going to be 18 inches high if using a 3.5 inch beam, or it's going to be 16 inch high if I'm using a 5.25 inch beam. So that gives you an idea of how those can be sized. But again, use the manufacturer that you are purchasing the LVL from. Do not use a generic table because you'll get bit in the butt if it fails. So, well, anyway, basically, let me just go back. Here's the best way to do it. Notice the note. Nope, not that one. pre-engineered steel truss header with all specs by manufacturer, period. That means that whoever you buy the LVL, the steel truss, the wooden truss, whoever you buy that from, the manufacturer is going to be responsible for sizing it. And that's just the only way to go. Unless you can pull it out of the code book, you let the manufacturers size those. So after you get to an LVL, then you can get to PSLs, which is a, what is PSL? LVL stands for laminated veneer lumber. PSL is parallel strand lumber, which is like, well, it's, you know, well, let's see.
I remember in the codes course.
What?
I remember both of those from the codes course.
Yeah. So when you're talking about a parallel, I didn't want that. I wanted pictures. When you're talking about a parallel span truss, it's kind of like, OSB. All right. So you're using strands, but they're all parallel. So parallel strand laminated lumber, much like the LVL, where we had the, you know, all of the grain was running in the same direction. So in a parallel strand, it's like OSB. OSB, we're using chips that are oriented, you know, back and forth, but in a PSL, all those are going in the same direction and they're glued together. So they're not going to be as strong as the LVL, but they'll be cheaper because we don't have to have whole trees or big trees to get this set up. And in this case, we can take smaller trees and chip them up. And then we just, there's a machine that will orient all of these chips in the same direction. And they can be made out of smaller trees. And they actually, you know, if we're using plywood, these can be used, what's left over can be used as those strands as well.
Where's the PVL? Is that it? Where's that used mostly?
I don't know what a PVL is.
Was it PS? I forgot. What was the second one?
PSL, parallel.
PS.
It can be used in the same place as an LVL. It just will not span as long as an LVL. It's kind of like, it's like plywood and OSB. Okay. Plywood is better than OSB. OSB is cheaper because it uses, well, I don't know, these days it's outrageous either way. They can use smaller pieces of lumber, smaller trees, and the same process. Okay, so I've run out of time. Danny, did I miss anything that I need to go over on Wednesday?
Well, I think we covered a lot. I don't know if we've really missed anything. The only thing I was going to add about the web trusses and the eye joists was that just like lining up your studs, you really want to make sure that you've got your orientations correct on your joists, because some of them have those pre-established cutouts, the only places you can drill. And those web trusses, the truss joists, they, you know, if you got that space for your HVAC, you want to make sure you lined it all up correctly so
Absolutely.
the HVAC can run through it. And then you got to watch out for those hurricane clips because they'll cut the rest of your ductwork up.
Yeah, absolutely. Okay, guys. Thank you very much and have a great week. I'll see you on Wednesday. And
What are we doing Wednesday?
we're going to start talking about BPI. Well, actually, we're just briefly going to talk about BPI, Building Performance Institute. We're going to talk about lead stuff. If Danny wants to, or not lead, HERS rated. Danny is a HERS rater, and I'm hoping that he'll share his experiences and stuff with me. And we're going to talk a little bit about lead.
And no homework over the break, correct?
You're off. I'm not gonna, I'm not gonna make you work off on a week that you're off. I'm just gonna give you twice as much work the week after.
Yeah.
All right, guys, have a good one. See ya on Wednesday.
See ya.
Thank
See
you.
ya.